Section 6.2 talks about trigonometric functions in the different quadrants. So we learn the unit circle and we learn the different parts have different values. Well, there's a logic to the way that um, all the points, even and all the values for the angles outside of the unit circle also work. So that's what we're really going to talk about. So let's say we know some sort of angle here, and we're going to call that angle theta. Well, if we know an acute angle theta, so one that's between 0 and 90 degrees, or you want to say 0 and 2 pi, or excuse me, pi over 2. If we know some angle that's there, it's going to have some sort of cosine and sine to it. So what do we know about other places on the circle that we can use to base off of that point? Okay, so that's what we're looking at. So this is just a very general video just to try to get the understanding of what I'm talking about. So let's look at the different options here. So if we know theta is there, so again, we have theta is this sort of angle here. Well, what would 180 minus theta be? So 180 is represented here. So we would take this same angle and we would subtract it to go to this side. Okay? So what would that mean for our points? So, what would, let's say, what would the cosine of 180 minus theta be? Now, of course, we need to know what theta would be to be that, but what we can say is that if we know what our regular theta is, we can go based off of that. So in this case, the cosine of 180 theta, it is opposite of what it would be in the first quadrant. So if we take the same angle here and subtract it from 180, we're going to end up with the opposite of cosine of theta. So that's a simple conversion that we can make. So if we know this, we can find that. It's kind of the idea. Now, what if we were talking about the sine? Okay, well, the sine of 180 minus theta. So how high up is it? Well, if you notice, the heights should be identical. So actually, the sine of 180 minus theta is the same as the sine of theta. So, if you think about the angles, like, for example, just give you an example, so like 150. 150 will be the same as 30, because they are the same distance off of the x-axis. Now, what about the last one? What about the tangent of 180 minus theta? Well, our tangent, what the tangent is going to do is it takes our sine divided by our cosine, or the slope of our line that we have drawn. Well, it's not going to make things quite perpendicular, but we can look at this right here and say that, hey, if we know that these two new angles here, it's normally our y over our x, or our sine over our cosine. We can look at this and say, okay, well, sine over a negative cosine is going to be now negative. And so this is actually negative tangent of theta. So we end up with the opposite value there. And again, remember we talked about tangent being positive here, negative here, positive here, negative here. You can kind of see that it would just flip in that way. So now let's look at a different place. What if we did 180 plus theta? So think about what 180 plus theta means. That means that we are actually on the other side of the circle completely. So we've gone 180 degrees all the way over here. So that's where we're talking about. So we're all the way on the other side. So the cosine of theta, okay, excuse me, 180 minus theta is actually its opposite, right? Excuse me, oh, this is plus. The cosine is opposite. It's on the other side of the circle. That makes complete sense. It's going to have to be its opposite. The sine of 180 plus theta is also the opposite, right? It is the same distance below that the other one was above in that same quadrant. So this is negative sine of theta. Now what about the tangent? The tangent of 180 plus theta, this one's interesting. It's on the other side of the circle, but it actually has the same slope as the other line that it connects to, because they're cutting right through the circle. The tangent of 180 plus theta is actually the same thing as itself, right? Tangent repeats itself actually every half circle, half rotation, as opposed to sine and cosine, which is very interesting. But you can find that on opposite sides, so 180 degrees apart, the tangent or the slope, kind of the symmetry of the angle is the same, which is very interesting. And lastly, we're going to do 360 minus theta. So again, we take our thetas here, 360 minus that. So 360 is the same thing as 0. So we're just going to take that and we're going to go backwards. So what do we see here with our points? And this is not the best drawn graph, but what we can see is that our cosine of 360 minus theta, that should be the same, because basically have the same x coordinate. This is the same. Now what about the sine of 360 minus theta? Well, the sine, they appear to be opposite, and they in fact are. If they had a better picture, you'd see that better. Negative sine of theta. And then we have our tangent of 360 minus theta. Okay, well the tangent, just like before, this is actually going to be opposite as well, that we had. So there is a symmetry to how this whole circle works. So in reality, if you know an angle that is in the first quadrant here, you can use this type of logic and thinking to find all other places on the circle, or in all other values for your trig functions that exist, just using a little bit of logic. So again, if we know the first quadrant, we can figure out the second quadrant, values of sine and cosine and tangent. We can figure out the third quadrant for sine, cosine, and tangent, and then we can figure out the fourth quadrant for sine, cosine, and tangent. Only thing that ever changes is just the sign of whatever that value is in the first quadrant. And just knowing, being able to picture it on the unit circle makes it very easy for us to figure this stuff out.